Alright, we're starting working another Bobber Sportster here. This one here is a 72. So he's been working on this for a few months and been having another problem with clutches, not working, among other things. The thing barely rolls because the brake drag's so bad. But anyway, I just took the cover off, got that off. And we got to see what we get to play with under here. So right off the bat, we are seeing lots of problems. So he has a racing style, sprocket style chain tensioner down here, which is not too good for the street because it tears the chains up, but it works all right, I guess. I use them on my race bikes, but it tears them up. He told me there's going to be some issues about the chain probably broke before or something and ate up the primary cover, or the case in here. So you can see how that's all eaten away in there. So that all has to be welded back in there. He didn't tell me about the one up top, he just said there was a couple on the bottom down here, like that one right there. So to fix this, I'm going to have to pull this whole motor sprocket out of here and get up in there and fix that. So more issues. But the reason his clutch doesn't work is because he's a 72 bike and he's got the stock clutch for a 72, which is this stupid ass adjustable design. It's one of the worst things Sportsters ever came up with. Harley didn't know what the hell they were doing. So instead of having spacers back here to tighten up against to hold it in a set position, it's all adjustable by all these nuts, and you can never check the adjustment because you have to have the cover on it to check it, and if the cover's on you can't see anything and do anything, so it's kind of a pain in the ass. So if your spring doesn't work perfectly correctly like it should, it doesn't work. In this case, it doesn't work. So he's been screwing with this thing for 2 or 3 months at least now, trying to make it work. And he's lost a few of the parts for the clutch mechanism also, so a few minor problems. So anyway, I'm going to go ahead and try to do this with one hand by myself. And you can see what this clutch looks like when I get it out of here. So, let's get our tools going here. So the fix on these bikes is once you get when you have these 71-2 style bikes, 73, I think they changed in mid-74, they got rid of this crap. So I always just convert everything to later stuff and get rid of all this early stuff. It never works anyway. It was already broken too, as you can see the stud was broken. I'm going to get both nuts out first. Hard to watch the camera what I'm doing at the same time. Okay, once you get that off, you get all these clutches out without having a tool. You unscrew this out to the last couple threads. You do a little one 180 across, like that, and then you go ahead and take all the other ones out. So it pops out. Okay, now this one here, it's going to spring out on you, so you got to hold this top one while you do it, or the bottom, whichever you want to do. It pops out. Then you do the other one. And while it's being held there, you just kind of come up here with your hand right here real quick. And it comes off as a unit. So you will have to have a compressor to put it back in though. So this is the, let's see, I think this is a later spring. The early ones were only about this tall as I recall. I'll double check it to make sure. The later ones were a little bit stronger springs on them. So this is your early cover. Now usually what I do is I cut all these damn studs out of here so you don't have to ever use it again. Or you just go up and get the later cover, it's up to you. If you leave them in there, they tend to grab a hold of you while you're working on it. I don't like having stuff grab a hold of me while I'm working on it. So all this crap right here we won't be reusing because we don't put this stuff back on. It gets eliminated. Okay, now we got our clutch. He was in here working on this, as you already can see. Things are only half put back together. So these have the early plates that do not have the slotted holes in here. So we're going to have to put new steel plates in here for sure. Probably want to put a whole new clutch in this thing, but we'll find out. Now you get a little retainer spring right here. You just pop it up like that and get under there and pull it out. You got to find out where the spring starts at. Must be up in here somewhere. Okay, it's not here. So let me just right here. So see how it pops out right there? Just grab with your finger, it doesn't get you. And there's your clutch spring retainer. Now at this point the whole clutch you just pull right out. We also have the hub loose, so the whole hub might come out too. But so there's your clutch. You got your outer plate here. You can tell how much wear is in here by how low it is here on these grooves. This is pretty low. So like I said, these steel plates are going to have to be swapped out because we're going to switch over to a different style. These steel fiber plates here look like they're not super old. These are definitely the old original steel plates that they haven't made in probably at least 20 years for sure. Probably older than that. So let's take all of these out here. Now the inner pressure plate here, that's the part with the studs on it, it's the same for early and late, so you don't have to change that. You just put they have spaces to go over these studs that set the height, so that's easy. Alright, so we want to look at the pressure plate, make sure it's not bent up too much here on the sides. You can look at it from the side view, and if it's kind of wavy looking, it's been over torqued and it's no good. This one doesn't look too bad. These are just pressed on little knurls underneath the heads here, these studs. So these are all seem to be tight. This is the original stuff because they're not welded. The aftermarket always puts tack welds right here. So this is an old genuine piece. The steel plates look like they're still good. See how they stack pretty evenly and flat. So if you want to mess around with this crap, these plates are still good. But as far as I'm concerned, they're trash because I'm not going to put that junk back in. We'll go ahead, probably looks like we'll reuse this steel, the fiber plates. So we'll just put new steels in here. So this stuff here is good. Okay, here's our hub. See how it's been loose in here running? There's a lot of wear in there. So I'm going to have to go put that in the lathe and machine that flat. Knock off 20th hour, so it ain't going to hurt anything. So I'll clean that up. I don't see any wear in here that really matters. Nothing much. You can see there's a little bit of wear right here on the edge. Yeah, the light might help a little bit. You see that shiny spot here on the inside edge? That's a wear mark. It's nothing super serious. So that looks okay. I'll just clean it up and save it. Well, this looks alright too. No major wear or anything, so it looks like the basket's good. This is the early basket because it doesn't have the reinforcement rib around it. So it's the earlier style. So it's no biggie. Alright, now this one here only has one bolt that holds it together, it looks like. This is just a slip fit here. So we're just going to pop off our bolt there. So grab a 9/16 socket here. There goes the puller. Alright, so just pop this off. There's our bolt. Pick up our puller down here. Okay, here's our plate. That over there. You can see how this just slides back and forth here on a stud. It's got an oil groove in it, so it gets oil. Pull this other one out. to pull this out like this, and it's not. Okay. Alright, I gotta pull this big nut off, so let me turn the camera off so I can change out the impact. Okay. Pull the nut off my air impact. I got my puller halfway on right now. So this is just basically a 2-jaw style puller, harmonic balancer puller, steering wheel pullers, all kinds of names for these things. Just a universal, either 2-way or 3-way puller. That's all you need. Just takes 5/16 coarse bolts ready to hold it in. You just pull that out until it sits evenly in here. Make sure you got the screw in the center of the shaft there. Tighten it up a little bit with your hand. Okay. So now we got this all on there. I'm going to go ahead and turn this with my zip gun here. I got to pull it off. Pull her out of the way here. Okay, so there's our sprocket. Our tensioner should be able to come out now. Fall out of one piece here. It's always fun to do with one hand. I usually do things with 2 hands when I work, so makes it hard. So you see the oil groove in here. Let's see oil through it. Through a hole. And it's got bearings inside of this thing. Get the light where you can see it. Pretty simple design. They work good, but they are hard to change. I like the ones that don't have the teeth in them nowadays. I've learned out that these ones tear up your chains. So if you get the ones that just have the 3 ribs sticking up, it's kind of like a skateboard wheel, except the skateboard wheels tear up the plastic, so you use steel. And they will tend to wear a little bit better, but it's a little bit easier on the chain. But the chain doesn't like hard metal against it, so no matter what you do, it's hard on the chain. This is the old style figure 8 style chain, so it's got the figure 8 looking links here. The newer chains are oval shaped, they come straight back and they're a lot thicker and stronger. They're probably about twice as strong as these early chains. So when you update stuff, I usually like going to the newer stuff, a lot stronger. You look at the seal area there, it doesn't look too bad. I don't see any cracks through there, so that's good. And all the teeth are on the sprocket, so that's always a good sign. If you want to know how bad the chain is, you take it and go like this and squeeze it. You go over here 180 degrees to go away. Oop. Helps to be all the way on the sprocket. One tooth off. Okay. So it's hard working with one hand here. Okay, we squeeze it again right there. And go over here 180 over. And you pull on it. And you see how much the tooth you show over here. This is how loose this chain is. And see, we're not moving the chain over here. This is just all clearance along this whole length. So this gives you an idea of how much clearance you got in your chain. It works on the back wheel too. If you can see half a tooth, it's bad. If you see more than that, it's really bad. Primary chains, usually if you can see a quarter of a tooth like this, it's getting pretty loose. So this chain's got quite a bit of mileage on it. It's still usable, but it's getting worn. It's definitely on the last half of its life, not the first half. The other way is you kind of take the chains off. You lay them on a table and you look at them. And right off the bat, I'm noticing it's kind of knotted up. See how these are tight. See those knots are in there? Chain should be laying straight up and down right now. So you can see all those knots in the chain's tight. And so you check these things like this, you go like this, and you rotate them like that, and you see how much clearance you get in them. And this one's relatively good this direction, but the reason that is because all these links are tight. See, these links are tight because of that sprocket over here. Right here. Making the chain go backwards because it rotates around this way and then here it goes the other way. That back and forth movement is hard on the chain here, but also this little small wheel in here. At high RPM, this thing's probably spinning 20,000 RPM or better. So what happens is it tears up these links in here and gets little burrs on them, and that's what makes the chain tight. Even though we know from over here, when we check it this way, it's loose. So this chain is definitely getting worked out pretty hard. So I'm going to recommend to the customer to put a new chain on it, but it's good for, you know, another year maybe, normal driving, but which means less than 5,000 miles. But, you know, it's up to the customer. When the chains break, you have problems like this. It breaks the cases. So I tend to like changing this stuff before you get to that point. And you can see right here, you get this nice custom repair job right here. It's got silicone in here, and it's obviously doing a really good job on sealing. So anyway, there's your nice piece of crap there. From what I can see on this, the reason this case is broken, which is not because there's some JB weld on this one. It's broken not because the chain got loose and tore it all up, because if it was, these would be all chewed up over here and up under here. These are the ones it hits on. And you can see right there how that one's broken. Right there. What happens is when you guys put all this stupid silicone on here to seal it, when the silicone's on the other side of the screw and you push the screw in, it hydraulics and it blows the back of the damn thing out. Because see, this is broken from this side here coming out because you packed the damn silicone in here from taking on off a couple times. The silicone winds up in front of the bolt or screw. You tighten the screw up, it hydraulically compresses and it blows the case out the back side and breaks it. So this is all from having dirty motors that were not cleaned out because you got crap down inside these threads. And so the first thing you do on all these jobs is you blow all this crap out of here. And the way you do that is you have these special blow guns right here that go down inside and go in. Now see, this only goes in this far until it hits shit. That thing is actually threaded in there about that deep. So you check this one up here. It goes in there that far, about the same. If you could see up in there, you would probably see that there's some crap in there, but this one here goes in that far, so every one of these is different. This one goes in that far. This one here obviously was plugged up here, so you can see the silicone I'm hitting on it right there. So when they put the bolt in here, this one here, they packed it full of silicone. See, this one goes all the way through because it's a thin case. It comes out the back side. It's hard to plug that one up. So all of these are broken out because of the crap in here that they didn't do it right. And he wants me to fix all those somehow, which means I'm either going to have to JB weld them like this, which is a quickie fix, but cheap to do, or I have to go in here and weld this all up with a welder, the TIG welder, and weld this whole hole up here. Most likely solid's the best way. Trying to cap over it's really hard to do. It's easier just to V it all out and weld the thing solid. But when the motor's assembled like this, it's very hard to do, and you run the risk of breaking the cases because you're going to put a lot of heat right here, and this is cold, so this expands and cracks right up through there. And you can't heat this motor up really hot because the cylinders and all that are all on here, and they're sucking all that heat out too. So it makes it really, really hard to weld stuff like this. So I'll see. I'll talk to the customer, see how he wants to do it, but I think we're going to probably do the JB method. Like I said, this one here is already broken, so I have to figure out what we're going to do. But the problem with this one's broken out this bad, there's not really anything in here to hold. You could put a helicoil in here, but there's nothing to hold it. So basically, you put the screw in there, JB weld it up with a little bit of oil in the threads, and leave it, and hope for the best. It's a temporary fix, but it might get them down the road for a couple of years without too much effort. But anyway, that's where we're at right now. So these bikes become a real fun thing to do. We get to fix all these problems we don't know about. So, but anyway, that's where we're at right now. We'll figure out what goes next.